Hi, everybody. Back. Welcome back to the Shuko Math Practice Lab, Learning Through Practicing. We are continuing on this unit talking about the limits. So right now we are in our practice set number 4. So for this practice set, we are going to talk about a very special function. We call this the greatest integer function. And I'm going to show you how to find the limits, for the greatest integer functions. And now here are the problems we're going to work on. And for some reason, the greatest integer function, a lot of students got confused about this function. So that's why I put this practice set here and try to make sure everybody can get a clear understanding of what is the greatest integer function and how to find the limit. Okay, as always, right now will be a pretty good time to pause the video and then try to work on the problems by yourself first. And then when you finish, and then you can resume the video and go to the whiteboard. And I'm going to show you how to solve it, and you can check the answers. Okay, so now I'm going to leave here and go to the whiteboard, and I guess we'll talk later. Okay, so let me go to the whiteboard, and you can pause the video if you want. Hi, everybody. I'm in the whiteboard, and are you ready to work on how to find the limit for the greatest integer functions? Okay, so now in order to do that, the first things we need to review what is the greatest integer functions here, right? So the way we write it, we said f of x is like, we use these notations here. It's not really a bracket, kind of have like the double lines here. So this is what we call this greatest integer function. So what is the greatest integer function? That means you find the value is the whole number, is an integer, which is the greatest one less than whatever you put in here. All right, whatever you put in the function. So let's take a look for examples here. Let's make sure we understand that, right? So for the positive number, I think it's pretty easy, right? So like if you have like a for example, if you have a 0.35, okay? So you want to find the greatest integer, which is less than 0.35. So obviously, what is this number is zeros, right? Okay, so now like for the other ones here, if you have 1.009 here, right? So if it's 1.009, so what is the largest whole number less than this value? Oh, it's ones, right? So that's why we give you ones here. So let's do a few more. So like, for example, if I have a 25.432, then what is the numbers here? Is what is the greatest number integer less than the function, this value here is what? It's 25 here, right? So that's what we say is the greatest integer. Okay, now I think most of the students, they got confused with negative numbers here, right? So the negative number, let's see here, let's start with negative 0.027, okay, doesn't matter. So it's negative 0.027 here, all right? And so what is the greatest number? Is the less than negative 0.07 will be what? Will be negative ones, right? You cannot choose 0 because 0 is greater than, right? Okay, so now let's take a look at another ones here. So if I have a negative 1.354, okay, so negative 1.354 here. So what is the largest number less than this one? So will be what? Negative 2. So it's kind of like you just go to here, you drop 1 through here, right? So let's try to do one more. So what happened to if you have negative 4.75, right? Like we say, it's kind of like just draw. So what is the less than negative 4.75? So it's a negative 5 here. All right. So that's why when you see the graph for the, the greatest integer function is here. So like when it is 0, it is 0, right? Anything between 0 and 1, like 0.35, 0.21 is always be 0. So it's like it's in here. But as soon as it's touched the whole number, when they become 1, will become ones here. Then everything between 1 and 2, like 1.5, 1.4 is still 1. So like here. And so, but when they touch 2, will become the 2, right? So that's why, that's what the function looks like here. So for the negative signs here, let's be careful, right? For the negative ones here, we said, okay, everything like between the 0 and the negative 1, like negative 0.27 will become what? Will become negative ones, right? So that's why the function is like this. Then everything between negative 1 and negative 2 going to be what here? Going to be negative 2's here, right? So that's why the functions go like this, that's right? So that is what we call this greatest integer functions here. That's why we also say this is a step functions, right? It's kind of like stairs, right? So you go up. But you know, the easiest way to remember is what is the integer? The largest integer less than the value inside that kind of a bracket here, all right? If you understand that, then I think our problems are going to be pretty easy, all right? So let's take a look at part A here. I'm looking for the limit x approach to -2 from the right-hand side, right? The positive signs here, that's what we said here. Then I have the greatest integer function x is here. Okay, so think about this clearly. So if x is an approach to -2's, right? This is a -2 from the right-hand side, right? It's plus, so it's from the right-hand side. That means all the value you put here is what? Is greater than -2. So the value here will be -1.99, -1.85, something like that, right? Because from the -2 to where? To the right-hand side, right? So what is the values here? So the values here will be what? Will be the largest value less than, so it's -2. All right, okay. So now let's take a look at the next ones here, right? So the next ones here, so they ask you what is the limit, part B is here. What is the limit x approach to the -2? Okay, so the x is here. So what is the limit x approach to -2 here, right? So now in here, we got this one. In order to get this one, remember when the limit, we always need to see what is the limit x approach to the -2 from what side? From the left-hand side here, right? So then this is x here. Okay, so like take a look here. If from the left-hand side, you are approaching from this number, that means all the values there you approach to could be -2.01, right? So could be 2.01 or like could be negative like a 2.02, -2.31, right? So it's always in this value. So what is the largest integer for this value? And less than -2.3, so will be what? -3's, right? Because the -3 is less than, right? That's why we say the greatest integer is less than the value inside. Oh, now you see here, this is -2, -3. Are they equal? No, they are not equal here, right? So what is the value here? So I know this one here is what is do not exist. Correct? Okay, so because, go back to our original limit definition, right limit has to equal to what? Has to equal to the left limit in order for the limit to exist, right? Okay, now let's take a look. Limit x approach to the 2.4, all right? Okay, -2.4, I think it's -2.4, right? Okay, so it's the limit is approach to the -2.4. Okay, for the greatest integer functions here, right? Okay, so as always, I need to do the limit x approach to the negative 2.4 from the left-hand side, and also I need to take a look at the limit x approach to the negative 2.4 from what? From the right-hand side, right? So let's take a look at what happens here. So this is my x, and then this is my axis here, right? Okay, so let's see the limit exists or not. Okay, so this is negative 2.4. Okay, so when you limit approach from the left-hand side, right? So it's a negative 2. Maybe 45, negative 2.55. So, but still is what? Right, so from here you will have the value is negative 4, like a 4.3, negative 2.57, something like that, right? So what is this will give you the largest integer less than, so what is here is negative 3. Okay, so now you take a look from here, right? So from the right hand side, so what is your number going to be is negative 3.5 something, negative 3.9 something, right? So you still less than this number, the largest integer. What is here? It's negative 3s, right? Okay, so now you say, oh wow, these two equal. So I know the limit when the x approach to negative 2.4 is what? It's negative 3. It's kind of makes sense, right? So that's why if you take a look at the graphs here, right? So it, the limit will exist between all the intervals, inside those intervals here. The only things here, the limit will not exist is those jump points, right? So that's what the part C is try to show you and try to do that. Okay, and now let's take a look the next ones here. So the next ones here, let's take a look at the problem D's here. All right, so the problem D's here, my functions here is, okay. So my functions here, f of x is equal to the cosine x. Of course, this is the greatest integer functions here, right? Then the x is from negative pi to pi here. All right. Okay, so now let's take a look here. And so this is part D. Okay, so let's take a look at limit x approach to 0, f of x. Okay, or so you can say that this is a limit x approach to 0, then the greatest integer function of cosine x. Okay, so in order to do this, let's do a graph. So when we see the graph of cosine, so maybe that will help. So here, this is a pi, this is pi over 2. This is a negative pi over 2. This is a negative pi, right? So this is 1. So this is what is my cosine graph, right? Okay, so now we want to find the x approach to 0. So you always do left-hand approach and the right-hand approach, right? So x approach to 0 from where? From the left-hand side, right? So x approach to the 0 from the left-hand side, cosine x is here. And let's see here. Okay, so let's take a look at this cosines, right? So it's approach from the left-hand side of 0. So when you approach from the left-hand side of the 0, right? So the cosine value is going to be closer and closer to 1s, right? So it will be like 0.99, 0.98, those values, right? So what is the values here will be what? Will be equal to 0, right? Because this value will be like 0.98, 0.99. So, but the largest value less than that is 0, right? Okay, so now let's take a look. And the same ways here, you need to do the limit x approach to 0 from the right-hand side, right? Okay, so from the right-hand side, this is a cosine x again, right? Okay, so here, if you approach from the right-hand side, that means you're approaching the 0 from here. So the value of your cosine function is still going to approach to 1. So it's 0.999 or 0.98 something, right? So what is the largest integer less than those value? Still is equal to. So how you see the right-hand side equal to the left-hand side. So the limit exists, yes. So what is the limit? Limit is zeros, right? Okay, very good. Now let's take a look at the part E here. The part E is limit x approach to pi over 2 from the left-hand side here, right? Okay, so from the left-hand side, and then you have the cosine x here, okay? So let's take a look here. When you approach from the left-hand side of the pi over 2, that means you approach from here, right? So the value of the cosine, we're getting closer and closer to 0. So for example, it will become 0.001 or 0.035, 032 or 035, right? I said if you get confused about the greatest integer function, just write it out, and then you will see. So that means you're kind of going to approach to 0 from the left-hand side. So the value going to be 0.035, 0.001. So what is the greatest value less than those numbers? Is zeros, right? Okay. Now let's take a look at the part F here. So the limit x approach to pi over 2. Now I'm going to approach it from the right-hand side here, okay? So this is the cosine x here. Okay, let's take a look from the right-hand side. That means you only approach to 0 from this end, right? So from this end, from the right-hand side of the pi over 2. So what will be you're going to get closer and closer to 0, but all your value is what? Is negatives, right? So it will be negative 0.001, negative 0.003, something like that. So what is the greatest integer value less than negative? It's negative 1s, right? Because it's negative 1. Remember we said the negative is going downwards, right? So now in here, are they equal? Unfortunately, they are not equal. If they are not equal, so that's why my G's ask me, what is the limit x approach to pi over 2 of the x here? What is the numbers here? Do not exist, right? Because the right limit is not equal to the left limit. So in fact, this is the cosine x functions, right? So if you are interested, so what is the, so if you see what is this greatest integer function of the cosine x is here. So here, this will be pi over 2, this is pi, this is negative pi over 2, this is negative pi. So in fact, these functions, this range is here, right? It's all between 0 and 1. So the greatest integer function will be between. So we'll all change this one, become to where? Become to zeros, right? So that's what is this curve going to change to. And then the next one's here, as you can see, this curve here, right? This curve is always less than, is less than 0 and between negative 1 and 0. So what is that going to jump to? Become negative 1s here, right? So the same side is here. So that's what is the graph for the greatest integer function of the cosine x. So that's just kind of the different way you can look at it. So that's why it discount, it's not a limit not exist at the pi over 2 here. Okay, so now let's take a look at our last problem here. This is problem H here. This one is also very interesting problem. So this is like f of x, so it's the greatest integer function of x, right? Plus greatest integer function of negative x here. Okay, so I'm going to find the limit x approach to 2. Okay, so when the limit of x approach to 2, the first thing is here, I'm looking for x approach to 2, the f of x, right? Okay, so first things I'm going to find the x approach to 2. As always, find the left-hand side limit. Okay, so my left-hand side limit, so this will be x plus negative x, okay? So be very careful here. Okay, so when the x approach to 2 from the negatives, you know, from the 2's, right? So here is a 2. From the left-hand side here, okay? So be careful here. From the left-hand side, all right? So from the left-hand side, that means it's in here, right? So you're getting closer to 2. So you will have 1.99, 1.89, some value like that. So what is the greatest integer less than those number? Will be what? Will be ones, right? Okay, now let's take a look. This is negatives, right? Negative x. So you know your x is going to be 1.89, 1.99. So what is the negative x? It will be negative 1.89, negative 1.99, right? Then what is the greatest integer function less than these numbers here? Will be what? Negative 2 here. So what is the final answer for this one? It's negative 1. Okay, so now let's take a look from the right-hand side. Okay, so this is from the right-hand side. See what happens here. Okay, like I said, you know, if you get confused with the definition, the best way is just write down a few numbers and then you can see that. Okay, okay, so right-hand side is, now I'm going to approach to 2 from the right-hand side. That means you're going to approach to here. So your value going to be like a 2.11, 2.05, those numbers, right? So what is the greatest number? Is less than those number? So what is this ones here? Will be 2's, right? Because the will be the negative, so will be the greatest number less than 2.11, 2.05. Okay, now let's take a look at negative x. That means those numbers become to the negative. So it's a negative 2.11, negative 2.05. Right? So what is the greatest number going to be less than negative? So what is here? This is negative 3. Oh, wow. They add up to the negative 1. So what happened here? So they are equals, right? So when they equal, what I can say is here, what I can say here is the limit is equal to what? Negative 1. So limit does exist. And now just let's take a look at what happened to the function value, right? So if I have f of 2 here, that means the function value, this is 2, right? Plus, what is negative 2, right? So we say the function value, the greatest integer, if you have an integer layer already, it would just be itself, right? So 2 plus 2, so it's equal to 0. So as you can see, the function value equal to 0, but the limit going to negative 1 here. As we mentioned before, function value not equal to limit. So probably is not continuous. And we're going to talk about it in the next unit in great details here. Okay, so this is how do you deal with the greatest integer functions, right? So remember what is the greatest integer? Is the is the greatest integer less than the value inside that bracket. So the negative values always go down to the next negative values, right? Okay, so that's it. Like I said, if you get confused with the definition, just write out a few numbers. And I think after you write out a few numbers, and you will be able to see it, and then you won't be able to make you won't make the mistakes here. I hope that this helped. Like I mentioned in the beginning, a lot of students got confused about these functions here. So I hope this practice set help you to clarify some of the concepts here. Okay, so it's nice to share this with you. So don't forget, practicing. That will make you getting better in the maths here. Okay, so the next topic will be very interesting. I'm going to show you how to find the limit for the absolute values. So that's another functions here. A lot of students get confused. Okay, so it's nice to talk to you, and I hope you feel very beneficial for this video. If you like it, okay, don't feel, feel free to subscribe to my channel, or, if you have questions, feel free to send me a comment. And then I will try to answer your question as much as I can. Okay, thank you very much for watching, and looking forward to talk to you again in the next video. Okay, bye. Have a nice day.